energetics flashcards for chemistry. Now, guys, I am gonna go through these flashcards as well. Obviously, I'm getting the PMT question papers daily. Probably be done in a week for that, and then these flashcards need to be done as well. And and then obviously practicals, mechanisms still be posted on that playlist. So a defined enthalpy change, and also a YouTube shorts. So I'll be posting a lot more YouTube shorts. Defined enthalpy change, heat energy transfer to reaction at constant pressure. State what this symbol means. It means that the substance is when there's standard states and the measurements were under standard conditions, and the standard states standard condition 100 kilopascal at 25 degrees Celsius. Heat enthalpy change is heat energy transfer to reaction at constant pressure. Bond enthalpy, energy required to break bonds, and bond enthalpy depends on the environment it is in. Exothermic reactions give out energy. Delta H is negative, temperature goes up. This is just GCSE recap. Endothermic reactions absorb energy. Delta H is positive, temperature falls down. Bond breaking is endothermic. Delta H is positive because we need energy to break bonds, so it needs energy, so it's endothermic. Whereas bond forming is exothermic. Delta H is negative, energy released when bonds are formed. Say a key fact about bonds in bonds forming. Stronger bonds release more energy to form, and stronger bonds also release more energy, but they also require more energy when they form. Mean bond enthalpy is the mean average energy needed to break a certain type of bond over a range of compounds. Why is mean bond enthalpy positive? As breaking bonds is exothermic, therefore mean bond enthalpy is positive. State formulas to calculate enthalpy changes using mean bond enthalpies. Enthalpy change of reaction equals total energy absorbed minus total energy released. Why enthalpy change calculated using mean bond enthalpies not exact? They use average values, therefore they are less accurate than enthalpy change calculated using Hess's law. Hess's law is total enthalpy change for a reaction independent of the route taken. But they use average values, therefore less accurate than enthalpy change calculated using Hess's law. Standard enthalpy of formation. Enthalpy change, 1 mole of a compound is formed from its elements in standard states under standard conditions. And standard enthalpy of combustion. Enthalpy change, 1 mole of a substance is completely burned in oxygen under standard conditions. Specific heat capacity. Amount of heat energy takes to raise the temperature of 1 gram of water by 1 Kelvin. And definition of Hess's law, total enthalpy change for a reaction is independent of the route taken. Now this one, describe how to use a graph to find accurate temperature change. It's part of a practical, but I was like put on the flashcards as well, I guess. So basically, let's go through it. Record temperature at regular intervals a couple of minutes before the reaction starts. Plot a graph of results. Draw 2 lines of best fit, one through the points before reactions started, one through the points after the reaction started. Extend both lines so they both pass the time when the reaction started. Distance between 2 lines is delta T. Is the accurate temperature change without any heat loss. How to use calorimetry to measure enthalpy change solution. Add known volume of acid to an insulated container, measure the temperature. Add known volume of alkali, record temperature of mixture at regular intervals, and then find temperature change using graph method, and therefore calculate enthalpy change. So guys, a lot of flashcard videos. I don't think I'll be posting any notes like I did before. It's just not time effective, and time is one thing I am running out of. So flashcards it is, and the flashcards are, I think, scientifically better for memory as well because of triggering the cues and all of that. But flashcards from now on.